name is Albert Rooks. I'm with a company called Small Planet Supply. We supply mechanical systems, tapes, membranes, envelopes, especially products for houses that use very little energy or passive houses. And ventilation is one of our basic subjects, and high efficiency heat recovery ventilation is something we do every day. Because we've invested so much energy in raising the temperature of the building or lowering the temperature of the building, we do a process called heat recovery. And heat recovery basically takes the energy that we would exhaust out of the building, grabs it through a simple flat plate heat exchanger, and then brings that heat back inside the building. Okay, so this graphic right here tells the story of heat recovery really quickly and concisely. It simply shows an X across a core. Fresh air coming in, crossing a core, turning into warmed air, going to the house, at the same time as extract air coming back from the house, crossing the core, and turning into exhaust air, leaving the house. Let's take a look at what's inside an HRV. Here's one right here. We'll take this cover off. This particular unit can be mounted vertically like it is, or it could be laid flat in a ceiling, and this would catch all the condensate and drain it out this tube. But when we open it up, we find that it looks a little complicated, but it's really a very simple tool, very simple appliance. We've got one fan here, one fan there, and we've got a large heat recovery core right in the middle. And naturally, the heat just moves off from the side that has heat onto the side that doesn't have any heat. We also have the opportunity to filter the air coming inside the house. A clean core allows the two streams of air to move at the same rate across the core, and at that same rate, with that length of travel across the core, that's how you get a peak energy transfer from one stream to another.
At the heart of every passive house is an energy recovery ventilator or a heat recovery ventilator. In this case, we have an energy recovery ventilator. This is the unit here. It's a Zendo Q600. The passive house is so well insulated and such a high performance envelope, we need a very small amount of heating, and that's why we're able to transfer that heat energy to the house directly through the ventilation system. So the heating and cooling system for the house is Daikin Altherma system. So this is an air source heat pump. So it's taking heat from the air in the winter. It works down to like minus 20 degrees centigrade. It will still pull heat out of the air, and we take that heat and then we put it into the air system. So on the exhaust side, we have the white tubes that you see up top here. So they're uninsulated tubes, and they're taking air from the bathrooms and the kitchen and other storage rooms. And then we also have the silver looking pipes here, which are the same as the white pipes, but they're insulated, and that's taking supply air to all the bedrooms and living spaces.
This is a unique system due to a couple of factors. The first one being that we are utilizing an air-to-water heat pump made by Daikin, and it ties to a couple of Comfo Post coils that are downstream of the airflow to additionally heat or cool the air to each room.
So in terms of filtration for forest fires, the Zenda unit here has two what we classify as MERV 13 filters. We're going to be using the Haven sensor from Tezoa, and we're going to be placing that within the ductwork of the system. So we're going to measure the incoming air, both before the filters and after the filters, and also the exhaust air coming out of the house. So we're going to know what's happening in the house and what's the quality of the air that we're putting in and out.
The integration process to home automation seems very seamless. There's only a couple of items to install, one of those being the controller box and the other being the LAN box. And those directly integrate into the Q600 very easily.
This is a heat recovery stack. So when you turn your shower on, hot water goes down the drain, comes down and heats this copper coil. Then heats the water and then goes back into your hot water tank. So instead of your water going in at say 15 degrees into your tank and having to heat up, it'll come in at 25, which over the period of time is very efficient in a way. So it'll save up to about 40 to 60% on your average house by installing one of these.
At Core, we make energy recovery technology for ventilation systems. It's what's called a counterflow heat exchanger, very high efficiency, and recovers the energy used to heat and cool the home. Any kind of building that has a forced air ventilation system, like a furnace and ducted air system, can use this technology. The BC Building Code is moving towards this type of a home design for every home. In the future, this will be the normal.